Welcome to Engineering Visualization channel. So today we are going to solve the Vtu-Caed model question paper. Okay, so here you can see the model question paper 1. In this I'm going to solve projection of point problem. Okay, this is a solid edge 2024 student version. Okay, first I'm going to draw an XY line. Okay, so we can make use of this video so that many of the students have been asked for the solving the model question paper of the CAD. Okay, for them I'm doing this. So guys, please make use of it. Okay, subscribe to my channel and share to your classmates and friends so that they can be benefited. Okay, so here with respect to the question here, so in the question what they mentioned here, so it is resting on the HP plane, say resting on the XY line. So you can see the question, a point A is on HP means it is nothing but the front view. That's why I have put a point and mention A dash. Okay, and now the length we should consider. So here the point, it is the top view lying in the first and fourth quadrant. In both first and fourth quadrant it is lying below the XY line. So that's why I'm drawing the length of 30 mm, so below the XY line. Okay, you can just see first and fourth quadrant, so it is below the XY line. That's why I'm putting it and mentioning it as A. Okay, now after that see the question, you can change the thickness here. Okay, this is the new version of the software, that's why I'm getting a little bit of time because the commands were of different type. Okay, so if you want this software I can share this. Okay, this is the, for top A it is 35 mm drawn, and then if it is a another point B is on VP. On VP means it is nothing but the on VP means it is nothing but the top view, and below HP. So below HP means we don't know how much distance it is. Okay, what they mention here, it is the line joining the front views makes an angle 30 degree to XY, while the line joining the top views makes an angle 45 degree with XY. So that means we should connect with the top views with an angle of 45 degree, front views with an angle of 30 degree. Okay, that's what given in this problem. Using this sentence we have to draw. So what I'll do is, here I'll be connecting the top views at an angle of 45 degrees. Okay, so from the top view I'll be drawing an angle line for a length of 45. So here just by randomly we can draw, and then we can change the angle here. So first I'm drawing one line. Okay, and I can change the angle here. Can change the thickness. Okay, so select the line and select its thickness as 0.13. Okay, now here I'll change the angle. Now you can see here I'll go to angle between. So before that I'll be drawing one smaller horizontal line here from at the top A. Okay, so go to angle between and select the angle between these two lines and angle you're getting in. Now we can modify, change it to 45. Yes, now it has been changed. Okay, this is what the top view connecting the angles. Okay, an angle of 45 degree. So you can see the question here. So another point B is on VP. On another point B is on VP means nothing but the top view, and it should be drawn on the XY line. Okay, so we know that the top views are connected by an angle of 45 degree. So from the top view of A already we have drawn an angle line at an angle of 45 degree. Now I'll put the point. So that top view we should be marking on the line passing the 45 degree and on the XY line. Okay, so the intersection of this 45 degree line and on the XY line. Now what I'll do is we'll be drawing another line which is of angle 30 degree. Okay, that is for front views like this. Yes, downward I'll be drawing it. So just randomly I'll draw it, and then after that I'll change the angle. Just randomly you can draw here. Don't worry about the length. Now we can change the angle. So this angle should be 30 degree. Okay, now you can see the top view on VP means nothing but the top view. It should be drawn on the XY line. Okay, another point is on VP and below HP. and they have not mentioned any distances, right? So we can put the point here, go to point and just change the thickness to 2 mm. Okay, and here I can put yes here. Now vertically downward is another point. Now we need to draw with the vertical line here. Yes, I can change the thickness of this line. So I'll be making it as 0.13 mm. Change it to 0.13 mm here. Okay, you can see here we should mention the points here. Okay, now mention the views here. So here this point is exactly B, small b, and this is B dash. You can see the top views are connected by angle 45 degree and front views are connected by angle 30 degree. Now we have to find out this distance. You can see what they mentioned. Find the distance of the point B from HP. Okay, so that distance we need to find out. So we just measure it using smart dimension. So that completes the problem, guys. Subscribe to my channel and like the video and share to your friends and classmates so that they can be benefited. Now we move on to the second problem, that is a line problem. So here what given, the distance between the end projector through the end points of the line AB is 60 mm. The end projector distance given 60 mm. Okay, the end A is 10 mm above HP and 15 mm in front of VP. So here first we need to draw the locus lines for the end point of the lines. For end point distance they've given 10 mm above HP and 15 mm in front of VP. So first what I'll do, I'll be drawing an XY line. Okay, and marking VP because we know that from projection of line onwards we need to use only first quadrant. Okay, so draw XY, write XY, VP, HP and Y. Now we need to draw the locus lines. You can see here 10 mm above HP and 15 mm in front of VP. Okay, so I'll be using here offset command. So selecting XY, so here I can define the distance. I'll type 10 mm here, so it will be above. So give accept. Okay, the same way I'll be drawing 15 mm below. Guys, anyone want this software, that is student version, I can share the link. Okay, how to download also I can make a video. So now you can see end B is 35 mm in front of VP. So the another end point of the line distance and they have given. Okay, so step by step I'm going to do it, so closely you can follow and try to understand. Okay, so in this problem they have given only here the line AB appears 70 mm means it is nothing but your apparent length. You need to find out the true length here. Okay, so first I'll be drawing 60 mm line here from this end. Horizontally I'll draw it. Yes, 60 mm. This is the distance between the end projectors. Okay, 60 mm I'll mark. Okay, after that we need to consider another drawing the another locus line, that is at a distance of 35 mm in front of VP. Okay, for and I'll be going to the offset command. So typing 35 from the XY line. Okay, XY line and draw. So it is also done. Now you can see we have done this till here. So now after this already I have drawn here 60 mm projector line, guys. So and here in the question they given the line AB appears 70 mm long in the front view, means it is nothing but the apparent length in the front view, that is A dash B dash distance they were given in the question. Okay, Complete the projections and find the true length of the line and its inclinations with HP and VP. Okay, inclinations we need to find out. So no inclinations given in the question, guys, here. Okay, so you need to be careful in solving this problem. Okay, so at the 60 mm what I'll do, I'll be drawing one vertical line. Okay, so that we can get the exact end points here. Okay, so this projection of line is totally the concept based subject, guys. So we should not draw line of length there. It is 70 mm this one, but I don't know the angle, so I cannot able to do it there. So because we don't know how much angle it is, right? You cannot able to do it. So you can see there are now vertical line I need to draw. It's totally concept based projection of lines, guys. Here as vertically one line I'll draw, as I mentioned, so that I can get the end point exactly here. Okay, where we have to end it. So at the end we are drawing one vertical line, guys, that is connecting top and front view, A dash, B dash, like that. The same way here also we are drawing it. Okay. So now in the front view I'll be drawing 70 mm line now. Okay, because we don't have any angle, right? So for that we need to do like this. So here to find out the commands little difficult because you're not used to it. Okay, so here can show the distance. So here the distance it is 60 mm. That's what I am showing here. Now again go to line. Here you need to draw a line of length 70 mm, that is upper end line. Now you can easily connect. Okay, yes, this is 70 mm upper end length, so you can mention A dash, B dash. Okay, one length we got it. Now this upper end length we should rotate. So we know that we always have to rotate the upper end lengths. We never rotate the true length of lines. Okay, guys, you can like the video, subscribe to my channel, and if you want to join, you can join for this membership. It is only 19 rupees per month, and it is you can cancel at any time. So take arc by center, measure 70 mm, because we need to rotate this. Okay, rotate it and then project downward. So rotating it and projecting downward, we get the true length now. Okay, just draw a vertical line here. Okay, so this is 70, you can show this is upper end length which is given. We need to find out the true length, right? So I have been projected till the locus of 35. Okay, I can trim it that extra length. Okay, so now join it. For the end points we should connect, right? So from A dash we don't have the exact point. From here I'll be drawing one vertical line downward. Yes, this point is A. Can now join this A and that end point we have joined, right? So join it, that is nothing but the true length. So to show the difference here, I'll be drawing this true length by thick line by 0.50 mm. Okay, so we got the true length. So we know the true length in top view exactly equal to true length in front view. So end points also we got it. So at the end point of B dash, I'll be drawing another locus line here. You know, wherever the end points of the lines exist, we need to draw these locus lines. Okay, I'll be drawing the locus line. So here exactly at this point I'll be drawing the locus line. Okay, so true length we already got it is 84.4. For the same length I'll be drawing the another true length. Okay, joining this locus line, type the same length. That is how much it is, 74.44, and enter. And then merge with this where it is exactly cutting this point, right? Just join there and show the dimensions. So it is 74.44, guys. That is true length, same. True length in top view and true length in front view will be same. Okay, now we need to get another upper end length. Upper end lengths will not be equal, guys. Okay, you know this concept, right? If you want to refer, you can refer my playlist of projection of lines. You can understand all the concept. So draw projection line vertically downward, go to arc by center. Now yes, in this command we get it. So select distance from here to here and then cut an arc till here, locus of 35. Yes. Okay, now you can join using line. So now we are getting another upper end length in top view we are getting. So this is AB, so we can mention that. So guys, we can measure all the distances, angle between and all. Okay, now we got it, both upper end lengths and upper end angles, true lengths and true angles, everything we're getting it. So just to zoom it little bit. Okay, sometimes you cannot able to get the exact line. So 29 degree, 31 degree, so we need to measure the angles, right? So guys, thank you all, thank you for watching my video. So subscribe to my channel and share to your friends and classmates who can be benefited, and you can join this my channel at a very less price of 119 rupees, and you can cancel at any time. Guys, thank you all, thank you for watching my video. So I'll be sharing another next videos of this model question paper 1, so you can get this solution definitely very soon. I'll be working on it. Thank you for your support. Thank you all. Thank you for watching video. Welcome to engineering visualization channel. So today we are going to solve the second problem, that is projection of solid in model question paper 1 Btu-Caed. So the question here, it is hexagonal prism, 25 mm side of base and axis height 60 mm. So first I'm going to construct the top and front view of it. So it is resting with one of its edges. Okay, so the starting here we need to construct an XY line and writing VPHP, writing the first quadrant. So watch the full video, you can able to understand all the problems related to this model question paper. So subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. Write XY, write VPHP. So to construct a hexagon, go to polygon by center command, take sides 6 and place the hexagon with respect to edge. Go to smart dimension, select any one of the sides and click on it. It will show dimension. Now you edit, type 25, enter. Okay, it will change the dimension. Since it is a new software, that is Solid Edge 2024, so I'm not used to this new software. Initially it will take some time. Okay, write the notations. So top face notations are visible, so that were written as A B C D E F. Okay, and bottom face notations are not visible, that are written within brackets. Okay, A1, B1 and C1 like that we write, but it should be written within brackets. So draw two diagonals, that is thin lines, to find out the center of the axis. So here center of the axis we write with O and O1. So O1 will be the bottom face center, so it is written within brackets. So draw the projection lines. So here axis height is 60 mm. So in the front view of the prism, it is a hexagonal face, rectangular face it is. So give the height 60. Yesterday I got to know the summary of my channel that around 11,000 students have been visited last week. Only 150 students have subscribed. So I want to appeal to the students that make use of this channel so that you can score well in the exam. Subscribe and hit on the bell icon so that you can get the latest notifications about the related videos about this channel. Okay, so write down the front view notations which are all visible, that are written within brackets. Those which are not visible, written within brackets. So select the entire thing, use the move command. Okay, creates a copy and drag it along the xy line. Now we need to rotate. So here inclination to HP, how much they given? 45 degree. So we have to incline with respect to base edge inclination. So go to rotate and here rotate at an angle of 45. So here the important thing here, you need to unselect the copy command because it will create the multiple copies of it. So go to rotate and select the base edge, give the angle 45 degree. Extend the axis using extend to next command. So check the angle. So angle here we're getting it is 45 degree. Now use the line and draw the projection lines downward to complete the second position top view. Okay, if any student want this particular software, that is student version Solid Edge 2024, you can comment me in the video so that I can create a link and I'll share the link in my video description. So write the notation for the top view. So top view, in the top view bottom face it is A1 B1 C1, like that you can write down. Draw a projection line from the O also. This is O1. Same way for the top face, you can write down ABCD. So to construct the second position top view, we know it is having three steps. First step is constructing an outer boundary line. So join all the outer points. Now write the visible face. The top face is visible. That means top face hexagon, it is visible from the top view. Okay. This rectangular face also visible. A1 and BB1 is visible. So bottom face of the hexagon prism not visible. So it should be written with the dashed line. Part of the hexagon, base of the hexagon here. So I will be selecting the dashed line. Finally, there is an axis you can connect. Okay. Now in this problem, you just see they have given angle of inclination to axis for both HP and VP plane. We know the concept for beta angle. If the angle of inclination, if it is given with respect to axis for both HP and VP, means it is beta angle. Correct? So see the question paper. Angle of inclination to VP, it is 30 degree with respect to axis for the VP plane. So angle and I'm drawing here. So here the first arc length we should be drawing at 60 mm. Okay, need to find out the beta angle, right? So front view, first position front view, it is 60 mm. So draw an arc for a length of 60 mm. By taking one reference point, you can give this as O1. Now where we have cutted the arc, right? So there we need to draw an locus line, horizontal locus line. Now second position axis length we should consider. Okay, it is 42.43. So again go to arc by center. Just move the cursor on the first arc. You'll get the reference point. Now type 42.43 and cut the arc. Guys, here I'm making videos related to solid software. Why? Because 80% of the marks it is there with respect to doing in the system, that is using software. That's why I'm not doing any sketches. I'm doing only in the software. Okay, so make use of the video, because this model question paper solution I'm doing it for for the request of many of the students. So you can share to your friends and classmates in the WhatsApp group so that they also can be benefited from this video. Okay, so now we got beta angle is 45 degree. So this is O2 and this is O1. Now we need to copy the second position top view. Okay, use the move command, creates a copy of it, and then copy using the axis point O. Now rotate and then place it on the angle line. So draw the projection line upward to complete the final position. So here when you are placing it, you need to be careful. So you need to place it on the exact line. Okay, sometimes mistakes do happen, no need to worry. You can change it and place it accordingly. Now draw the projection lines upward to complete the final position. Like this randomly you can draw, or there is another method by which we can connect exactly with the pinpoints. Okay, draw the projection lines like this also. Just move the cursor over that point and then bring it back, so where you want to exactly end, you can end it like this. Guys, you can subscribe to this channel and share to your friends and classmates in the WhatsApp group. They also get benefited from this. Now you can write the namings here. First I will start writing from the bottom face, A1, B1, C1, like that. You can see the intersection point and then write. Okay, in the same way we write the notations for the top face also. I think in top face the projection lines we have not drawn properly. We do it again. So in the exam, no need to get panic, guys. You can take your own time, and the main important thing in this subject is you need a little bit of practice. You need to understand the subject properly, and then do little bit of practice, so that will be enough, so that you can easily score. So this is one of the scoring subject in engineering. Okay, so we can write down the notations like this. So here F and E are the nearest points. So if we connected with adjacent edges of the dashed lines, okay. So now we are making the thick lines here, thick and thin lines. So here the remaining diagram we have written with the thin line and making it as thick. We're selecting and making the thickness as 0.50 mm, okay. Okay, here now the problem is completed. Thank you guys, thank you for watching my video. Subscribe to my channel and share to your friends. Now we are moving to the problem number 3 in the model question paper 1 Vtu-Caed. So question number 3, it is the isometric projection. So here given it is nothing but combination of cylinder and rectangular block. Okay, so to construct here, first we need to take one horizontal line as a reference. From this reference point I'll draw one line, that is line with an angle of 30 degree. So here I'll take 60 mm, okay, and angle will take 30 degree because in isometric we should use angle 30 degree. Okay, first I'll be constructing an rectangular block. Okay, so here the rectangle block having base sides 30 mm 30 degree and vertical edge 60 mm, angle is 90 degree, again length is 30, angle is minus 150, and then vertically downward you join with a length of 60 mm. Okay, now we have to give the width here. So width of 30 mm at an angle of 150 degree. Okay, so the same line I'm going to transfer it using move command, creates a copy, then place it like this, so it will reduce your effort. Okay, now complete it so that rectangle block will be over. Okay, now we have to draw the cylinder. So cylinder, it is there exactly at the center of the block. So the total length is 60, means we need to subtract by 15 mm. So just see, so watch the video till the end, you can understand. So vertically downward by 15 mm, I'm coming downward 15 90 degree, and then 30 mm, then angle of 150. Again here, now the length required for the box, it is 30. Okay, again horizontally. So this is the box we require to construct the ellipse here. So from this corner point to the midpoint. Okay, again from this corner point to midpoint. Okay, from this corner point to midpoint. Okay, from the corner point to the midpoint you can select the line. So now using for arc by center method, that is using arc by center method. So here we will be constructing an arc here to construct the ellipse, taking this length, draw an arc. Same way from here to here, take this length, draw an arc. Now for the third point, okay, take this as a reference point, taking this line, draw an arc. Okay, and same way here also, take this length and draw an arc. So we have completed an ellipse here. Same way we need to construct another ellipse at a distance of 60 mm. For that, as a reference, I'll be considering a length of 60 mm, and then another box of ellipse I'll construct. Okay, for a reference I'll be taking this length. So length of 60, angle minus 150. Because we should be extruding at a distance of 60 mm, right? That's why I'm considering this length of 60, angle minus 150. Okay, from all the four corners of the box I'll be extending the same length 60 mm, and angle is minus 150. Okay, now here we got the endpoints. Here we need to construct an box here. Okay, subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. So it is important, guys, you should go through all these model question paper. There may be chance you can get the same questions for the exam, because the question paper, it is coming from the VTU. So make sure you go through all the problems, because we don't know which problems may be coming for the exam. Okay, in each model we have 50 different questions. Okay, just go through my videos wherein I have explained the problems with all concept with less time. Okay, guys, make use of the videos, and during the exam time it is very helpful that you can revise this subject using my videos. Okay, because you may be forgetting all the concept, because the practical exam, it is there after 1 month. Okay, so draw a diagonal line. Okay, now join from this end to this end. Again, join from this end to this end. Okay, so now we need to make these lines as thick lines. Okay, so rectangular block also I'll make thick by selecting all the edges. Thank you all. Thank you for watching my video. Subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. Thank you all. Now we move on to the next problem, that is development. That is question number 4. So so watch the video till the end, you can understand all the problems. So here we need to construct a square pyramid of base heads 40 mm and height 60 mm, resting with its base on HP, with all its base edges equally inclined to VP. So that means we need to construct a square lamina with respect to corner position here. Okay, so square pyramid, it is resting with the corner position. Equally inclined to means it is nothing but corner position. Remember it, guys. So first I'll draw an XY line. Okay, go to rectangle by center. So take thickness 0.50 mm, give width 40 mm, height 40 mm, and angle is 45 degree. Okay, width and height both are same in square. Okay, and give the angle 45 degree. Yes, you got the square lamina with respect to corner position. Measure the dimension. So here height of the square pyramid, it is 60. So give the namings A, B, C, D. So since it is a pyramid, we need to draw the inside lines, that is slant edges should be dark. Okay, inside line should be dark because it is a pyramid and it is having slant edges, right? O1. Okay, so now draw the projection lines upward. So make sure you draw the straight lines by zooming in. Okay, just scroll it, you can zoom the. Now height given 60. So take an axis, give the height 60 mm, construct triangular face now. To show the dimension. So top and front view of the square pyramid is done. Here they've given a cut plane which is inclined at an angle of 60° to HP, passing from the right corners of the base, right extreme corners of the base. So in the problem, right extreme corner is C dash. From C dash we have to draw an section plane at an angle of 60° to HP. So take section plane from the C dash end and draw an angle line. So just randomly can draw like this, and then you can change the angle. Okay, yes, you can give how much you're getting here. Can now change it. So angle, it should be 60°. Okay, now we have drawn an section plane. Now we have to mark the cut points here. Okay, so cut points will be marked with the numericals. So cut point 1, it is cutting on a slant edge AO, and 2, it is cutting on a slant edge BO. Okay, and cut point, it is occurring at the extreme corner 3. Okay, 3 is occurring at C, and then 4, it is cutting at DO, that is slant edge. Okay, so cut points are mentioned, and this is what our slant edge, because the CO slant edge is parallel to XY. No need to find out extra slant edge, it is already available. So draw a straight line for length of this slant edge length. Okay, now go to arc by center and draw an arc by taking this length. So randomly you can draw an arc. Okay, no measurements, just randomly like this you can draw. Now we have to cut this arc into 4 equal parts. It is 40 mm we need to cut. So take arc by center. So from this reference point, cut a length of 40 mm. Again cut an arc for a length of 40 mm. So that's why you give the radius 40. So cut it like this. Again 40 mm you need to cut. Again take reference point properly so that you can doing the problem correctly. Okay, so now join all these cut points with the vertical line. Draw triangular faces. Okay, 4 triangular faces are done. Yeah, now we have to draw an base of it. So just drawing it we can do. So now write the namings here. O, capital A, capital B, capital C, capital D, and capital E. Okay, now these cut points, right, we need to transfer on the slant edge length. Okay, So we have marked the cut points on the yes, these cut points were the right 1, 2, 4, and 3. You need to transfer on the slant edge. So like this, you draw horizontal line till here, and then from here to here. Okay, now right. This is 1. This is 2, 4. Guys, it take a lot of effort to solve these problems. Okay, it is because of the request of the students I'm doing these problems. Okay, so please make use of the videos and subscribe to my channel. Okay, so last week around 11,000 students have visited my channel, but out of the 11,000 only some 150 students have subscribed. So it is not a good thing, guys. So whoever is watching the videos, please make sure you subscribe and hit on the bell icon so that you can get the latest information about this drawing subject. Okay, this is very important because you're in the first semester or the second semester, and this is one of the scoring subject, so that you can make use of it. Okay, and one of the biggest advantage of this channel is that you can revise for the exam for within a less time. Okay, because the here the videos are made according to the student mindset. Here we need to cut the arcs. Okay, arc length for 6.54 on a OA. So on two sides we need to cut this because we have OA on two sides. Yes, this is 6.44 radius. You can type and cut it. And then on OB and OD it is 12.17. Cut 12.17 on OB and OD. On both it is acting on an extreme corner, means directly we can write 3 at the cut point of, so you can mention the naming now. 1 here, also 1. Okay, sorry, that is the 1 only, not 4. This is 2 and this is 4 and this is 1 again, and 3 we are getting here. Okay, so now we need to join this. Now we need to join all the. Okay, thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you all. Thank you for watching my video. Guys, you can share in the WhatsApp groups. Thank you all. Thank you for watching my video. Welcome to Engineering Visualization channel. So today we are going to solve the model question number 2, Vtu-Caed. So here in the question number 1 given, it is a circular lamina inclined to the VP, appears in the front view as an ellipse of major axis 60 mm and minor axis 40 mm. The major axis is parallel to both the HP and VP. One end of the minor axis is in the both the HP and VP. Draw the projection of the lamina and determine the inclination of the lamina with the HP plane. So in this problem we have to use the dimensions of the ellipse, that is major and minor axis. Okay, circle dimensions they have not given, and it is occurs in the front view. That is, we need to use major axis of the ellipse 660 mm in order to construct the circle. Okay, this is one of the special type of problem. Okay, So in this problem they have not given any kind of inclination. We have to use the data which is given in the problem to solve the problem. Okay, so first we'll be drawing an xy line and writing vphb. Okay, so here the first position will be in circle, but for that circle they have not given any dimensions, but they have mentioned the dimensions for the ellipse, that is major axis 60 mm and minor axis 40 mm. So the major axis of the ellipse will be the same dimension as that of the circle. Okay, so this is, I think, the last problems what we get in the solution book. Okay, so that means you can expect any question in the exam, because this time the question paper it is coming from the Vtu. You can expect any problem. Okay, so better to refer all the types of problem with the solution. Okay, here I'll be constructing an circle using center method. So diameter will take directly the major axis dimension here. Okay, so in the question given the major axis it is 60 mm, that means we'll take the same diameter, that is 60. Enter. Okay, now we need to divide this circle into 4 equal parts. So watch the video till the end so you can understand the concept and how to construct in the SolidEdge software. I think this problem I think I have not done in my YouTube channel. So using extend to next command, you can extend these lines. Now write down the namings and draw the projection lines downward to construct the top view. Write down the notations and then project the lines downward to complete the top view here. Okay, so if you want the solution of all the problems in the drawing subject, so you can subscribe to my channel and hit on the bell icon for the latest notifications you can get, and share to your friends and classmates in the WhatsApp group so that they also can be benefited from this. Draw the projection lines downward to complete the top view. So here I am finding little difficulty in this software because it taking too much time to load. Okay, that's why I'm, otherwise I could have done this problem within 10 minutes. As I'm clicking and dragging out, it is taking more time, I don't know. Okay, so first position we have done. Now we'll write the namings of the top view. Last week around 11,000 people have been watched my channel, but out of 11,000 only 150 students have subscribed. So I request the students who are watching my channel, so please subscribe, okay, so that it will be beneficial for me also, okay. Okay, now in the second position we have to draw the ellipse here because we don't have any kind of inclinations in the problem, okay. So here the major axis dimensions, it is 60 and minor it is 40. We have to use these major and minor axis to construct the ellipse here in the second position. Then after that we will find out the angle, okay. So for that what I'll do, I'll be just projecting this major axis dimensions horizontally. Okay, this is also the 60 mm only, the major axis. Then from the middle I'll consider the minor axis distance 40 mm, that is I'll be drawing on the either side by 20 mm. You can see in the question. So minor axis 40 means 20 mm we have to draw on either sides. Now draw the ellipse using ellipse by center point, okay. Guys, you're having exam after say some 1 month, so you may be forgetting all the concepts. So my recommendation is that you can refer my channel for revision purpose, okay, because I have done the problems both in sketchbook and in solid software, so that you can revise easily with minimal time. It doesn't take too much time for revision because the problems were done in a very stipulated manner, so that every student can understand it easily, and within very less time you can revise it, because you may be forgetting all the concepts like normal type, beta angle, like that, okay. So my request is that you can refer, because with respect to the playlist I have created all the content with respect to the VTU syllabus, right? Projection of points, projection of lines, or it can be projection of planes, projection of solids, okay, isometric projection and development of lateral surface of solids. So with respect to the playlist, I have created separate playlists. Say for sketching also separate playlist is there, and for this practicing in the system, that is using solid software, so that is also I have created separately. You can refer those videos, so it can be helpful. So no need to worry that you don't have enough time for practicing after the theory exams. You have only say one day. So it's better, what I recommend is that after your theory exam, say not like theory you can't able to revise in one day, say in between the theory exams, like you will be. Welcome to engineering visualization channel. Today we are going to solve problem number 2 in model question paper 2 of computer aided engineering drawing, okay. So it will be beneficial for you people if you need to watch this video until end, so that you can able to understand each and every step of this problem. And this is one of the important problem, that is problem number 2, that is in projection of solids tetrahedron. A tetrahedron of 50 mm side rests on one of its corners, such that edge containing that corner is inclined to HP at 50 degree and VP at 30 degree. So this is one of the special type of problem. So in this okay, this so the same problem I have taken from the solution book. Okay, like this we need to construct in the solid software. Okay, this is the same problem we need to construct. So just for the reference I've taken like this, the same thing we need to construct. Okay, it will be easier for me to construct it is. Okay, so go to solid software, draw xy line, write hpvp. Okay, and xy line. Okay, because the problems we are constructing in the first quadrant. Okay, we need to construct this triangular face. Okay, go to polygon by center, make sure the mental relationship should be on, select three sides, thickness 0.50 mm. With respect to edge we need to place it. Okay, same problem has been asked in the model question paper 2. Okay, so give the length 55, enter, it will change. Now draw the projection lines. So here we need to draw median lines. Two medians are enough to find out the center, since it is a tetrahedron. It is one of the pyramids, so we need to draw the all the three slant edges. Okay, now write the namings for it. ABC bow O1. Okay, draw the projection lines upward. Okay, in this we don't know the axis length is this tetrahedron problem. Just randomly need to draw, and from on this end, from the one end which is parallel to x, so you can see why it is parallel. That's why we are cutting the arc from this end of length 55 mm radius. Cut the arc. Okay, now join it. Guys, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, you are going to get all the problems solved from the model question paper of the Vtu-Caed. Okay, so it will be beneficial for you. You can share this video in your WhatsApp group so that your friends and classmates can be benefited. So we are writing the front view notations: B dash visible, A dash not visible, O1 dash and O dash. Okay, next in second position it is nothing but inclination with the base edge here. Okay, now we'll select this front view and go to move command. So here we are rotating, so we need to copy along the xy line and then we need to rotate and give the angle. So for this base edge, so angle is 50 degree. So it is yeah, this is what the angle we get it. Guys, you follow this procedure. Okay, now project it downwards to complete the second position top view. Write down the notations. So first we need to construct the outer boundary line, guys. In the second position top view, we follow the same steps. So zoom in to get the exact point here. Okay, construct the dashed line as it is in the question. Now we need to find out the beta angle here. Okay, so mention the axis. So here in this problem they have given angle of inclination with the edges here, but the concept of beta angle is that it will be there with respect to axis, but it is one of the special type of problem. Okay, here in this angle of inclination they have given with respect to the edges for both HP and VP plane. That's why it is also the beta angle problem. Okay, angle 30°. So minus 150 if you give, it will take 30°. Okay, now here the slant edge length you need to use, that is 55 mm. So go to arc by center. So take 55 mm length and cut the arc. Okay, now draw the locus line. So another length we have, that is slanted, is 35.16. So these two lengths are required. So one length already we have drawn. Now we need to draw an locus line here, horizontal dashed line. Okay, so cut second arc using arc by center. So just move the cursor on the first arc, you will get the reference point. Now type the radius 35.16 and enter and cut the arc. Now join this second point which I have cut it. Yes, zoom in and get the point. Okay, so just extend this line using extend to next command and find out angle, beta angle. So it is 51°. So we are getting an exact angle here, guys. We are doing correctly. Guys, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to your classmates and friends so that they can be benefited. So using move command we have copied. So take the reference point of OC and place it on the angle line here. So place it pinpoint. You can zoom in when you're placing it. You can zoom in and place. Okay, so now draw the projection lines to complete the final position here. Okay, after writing the notations, you can join it first. Join the triangular face and then the slant edges. If any of the slant edges passing inside, that will be dashed line. So passing outside means it is continuous one. So the dashed line from here, from this end to here. Okay, and then finally we need to draw an axis. Okay, that completes the problem. Thank you guys. Thank you all for watching the video. So subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you all. Welcome to Engineering Visualization channel. So today we are going to solve question number 3 in the model question paper 3 of Vtu-Caed, computer aided engineering drawing. Okay, so make use of the video. You can watch till the end. You can able to understand each and every step of the problem. So here the problem number 3 of the model question paper 2, it is nothing but isometric problem. Here a sphere of diameter 50 mm rests centrally on a cube of sides 50 mm. Draw the isometric projection of the combination. It is nothing but the problem number 1. Okay, so you can see in this question, so we need to construct a cube. Above it we need to construct the sphere here. So first I'll be drawing an reference line. So please follow the step by step. You can able to understand the problem clear and easily. Okay, so reference line drawn. Okay, here we need to construct the cube first. So this cube of sides 50 mm. 50 mm means we need to consider 50 mm box. So here please consider the angles. So from this reference end, length will be 50, angle is 30°. Okay, again length is 50, angle is 180°, 150°, sorry. Then another angle is, again length is 50, angle is 210°. So like this we need to construct the box. Okay, now vertical height we need to give the height of 50 mm. One line I will draw length of 50 mm. Okay, Then go to move command, creates a copy of it, or either you can directly do it like this. Okay, length 50 mm directly we can do. Angle is 90 degree. Okay, now construct the top face. So here the cube construction, it is done, guys. The cube we have constructed. Above it centrally we need to place the sphere here. So that is also having dimension 50. But guys, you know that sphere will be constructed with the actual scale, but the cube we need to convert into isometric here. Okay, so that is the important thing you should. Okay, you can keep it like this. Then you can show the angle. And this is one of the basic first problem of the isometric projection, guys, and this problem can be asked in the exam. Okay, so find out the midpoints. Height we need to find out. This is the center of the box. Center of the sphere will be find out. The height will be 25. Okay, now after finding out the height, we will convert into iso. Okay, so this step you remember, guys. Go to scale here, type here 0.816 or 823, can type it. Okay, now go to circle and draw here. That's what the center of the sphere. Now go to circle and draw circle of diameter 50. Enter. So that completes the sphere here. So always remember, sphere will be drawn with the actual scale, other solids will be converted into iso. So you can check the dimensions here. This will be 50 sphere actual dimensions, but if you check the dimension of the cube, it is less than 50. But after converting to iso, it is converted into less dimensions. Okay, thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you, guys. Thank you all. Welcome to Engineering Visualization channel. So today we are going to solve problem number 4, that is development problem in model question paper 2 CAD. Okay, computer aided engineering drawing. Okay, you can watch the video till the end. You can understand each and every steps of this particular problem. So we are solving the problem number 4, that is development square pyramid problem in model question number 2. You can see square pyramid given, base 40, side and axis 60 mm long, has its base on HP and all the edges of the base are equally inclined to VP, and it's cut with an inclined plane 6. Okay, the same question which I have taken from the solution book. Okay, here it is easy to study and do the solution. Okay, we cannot just go and back like that, so that's why I have taken like this here. So here first we need to construct a square pyramid of base 40 mm and axis 65, and it is resting with edges of the base or equally inclined to VP. Equally inclined to VP means it is nothing but resting with the corner position. Okay, and then it will be cut by a section plane. So first we construct the top and front view of it, and then the section plane. Okay, step by step we are going to do it, so please watch it till the end. You can understand all the steps, okay, easily. So go to rectangle by center. Here the width and height we have to give, that is 40 and 40, and angle will be 45 degree. So this is how we construct the square with respect to corner position. Okay, show the dimensions and write down the namings for it. Write xy HPVV and draw the projection lines upward to construct the front view. So here top view notations can be written ABCD. Since it is a pyramid, that means we need to draw the slant edges, that is thick lines we need to draw here. If it is a prism means it should be thin lines. So you all should know this difference. So thick lines we have drawn. write down O1. Okay, now draw the projection lines upward to construct the front view. So projection line should be thin line, that is 0.13 mm. We should take thickness. So axis height is 65 mm. Take the same length. So construct the triangular face. Show the dimension of the axis. So front view, it is done. Now here we need to draw an section plane, that is truncated surface at an angle of 40 degree. Okay, so exactly midpoint we need to find out, because it is bisecting the axis, means exactly half 65 half is 32.5. so here at this point we need to draw an section plane at an angle of 40 degree. So the length can be anything, but here angle you have to show with respect to axis. It is given in the question, it is 45 degree, guys. So it exactly this, right? So this is a section plane. Now can mention the, so that upper portion I am going to make it okay lighter, in order to show that the lower portion has been the cut portion, the truncated surface. Okay, now I'm mentioning the cut points here. So it is cutting the, so you can mention this front view notations: E dash, B dash, C dash, and D dash is not visible from the front view. O1 dash and O dash also can mention. Now I can mention the cut points. So here cut points we are mentioning with the numericals. So 1 is cutting the slanted JO, 2 is cutting the slanted BO, and C is cutting the slanted CO, and 4 it is cutting the slanted DO. Okay, okay, mention the cut points like this. Then measure the slant edge dimension. So here you need to find out the slant edge dimension, use 2 points. So here in the dimension they are showing horizontal, vertical, right? So this length also you can take, because that is also a slanted edge length. Okay, just for reference I'm drawing the slanted edge here because I have split it there. Okay, now we're getting the slanted edge length, same length we got it. Now using this slanted edge length we will construct the development of it. Same, for same length we'll be drawing a line. Now we need to transfer all these cut points on the slanted edge length. Okay, 1 and 4, this is important step, guys. You should do it. 2 and 4, and this is 1, 3, it is already there on the slanted edge. Okay, and you need to measure this length because we need to cut the arc on the slant edge when we are drawing and this development, right? We should know these dimensions. The slant edge lengths we need to find out. So for this I'll be using split command to get the exact length here. Okay, so in the distance between command there is an option here. So distance between 2 points, if you select, so you can able to measure the dimension. Okay, this is important step, guys. You can make use of this particular command. So select these 2 points. This will give the slanted line. Same way from this end to from this end. So again you have to select this particular command. Again you need to yes, like this you can measure. Yes, we got all the section point length on the slant edge. Now we will construct the same slant edge length here. After drawing a vertical line, we need to draw an arc using curve by center command. Okay, use arc by center command here. Yes, center point, and then draw an arc. Again here we need to use the arc again because 40 mm lengths we need to cut. Guys, in order to solve this problem it takes a lot of effort, so please make use of this video and subscribe to my channel and share to your friends and classmates so that they can be benefited. I am solving this model question paper because many of the students have been requested me. That's why I'm doing it. If you found this video very helpful, you can super thanks. There is an icon in the YouTube as you are watching the video. There is a little bit like sharing like button, but after that there is a particular icon like heart wherein you can, if you want to donate to this particular channel, you can donate it by super thanks. It starts from say 40 rupees. How much you want to pay, can do it, there is no problem. If you found this video helpful, you can do it. Okay, you can join like this. Connect all the arc cut point which you have cut it, right, using vertical lines. Okay, like this you can connect it. If you're finding any disturbances during the video, so you can neglect it, so concentrate on the video so that you can able to practice it. Okay, so like this you can construct, because it is having four since it is a square pyramid. Okay, so join it like this. So dimension we can measure it and give the naming for it: capital B, capital C, capital D, and capital E. Okay, and A again. Now the cut points we should mention the dimensions which I have already measured for on the slant edge. Okay, A1 the same length arc we should cut. Similarly for 2 and 4 it will be the same length, and for 3 it is the length which we measured. Okay, go to arc by center and type that same radius for. Welcome to engineering visualization channel. Today we are going to solve model question paper 3 VTU computer aided engineering drawing. I welcome all of you students for this particular session. So in this particular video we are going to solve problem number 1 in model question paper 3. Okay, so you need to understand. So here in the model question paper 3 they will be giving a question that is equilateral triangle problem with beta angle. Okay, So watch till the end. You can able to understand each and every steps in the problem. You can see equilateral triangular lamina of sides 50 lies with one of its on HP. The lamina makes 45 degree to HP and one of its medians is inclined at 45 degree to V. Okay, here angle of inclination they have given with respect to median. That means it is an beta angle problem. So in this problem they have considered 50 Okay, I will not consider 50. I'll take for showing purpose I will take 25 and then I'll construct. Okay, so beta angle problem. So I'll show in the solid software. Guys, if you want to see the same type of problems like model question papers, all the types of problem, please subscribe to my channel and hit on the like button and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. So first I'll writing then xy line, writing HPVP since it is lying in the first quadrant. So go to polygon by center and select number of sides as 3, give number of sides 3 and resting with respect to edge. Okay, now go to smart dimension, select the vertical edge here, give 25. I'm showing this problem in 25 dimension. Okay, the same thing you can do it in the exam for 50 So based on the question given, guys, you need to do it. Okay, but for showing purpose I'm doing it for 25 Okay, so the procedure will be same. So draw the projection lines to complete the top view. If you have any doubts or queries regarding this subject, you can comment me or you can WhatsApp me, because I have shared the WhatsApp number in the YouTube channel. Okay, and if any problems you are not able to do it, you can personally share to me in the WhatsApp group so that I can help you. Okay, in solving it I can share you personally in your WhatsApp group. Okay. Guys, this is one of the scoring subject wherein you need to understand the concept and practice. Okay, little bit of practice so that you can score more marks in this. Okay, in this semester you will be having question paper coming from the VTU. Okay, so what I recommend you people is that you go through all the types of problem. Okay, first you know how to construct them and then concept and then practice. Okay, so like that you can solve this subject and score this subject very easily. Okay, for similar type of videos if you want, okay, related to VTU computer aided engineering drawing, you can subscribe to my channel. Okay, angle of inclination here I'm taking 40, it is 45 given. With respect to that you can take that. Okay, the procedure will be same. Now we need to do the beta angle here. So median we need to draw. Okay, so two medians we need to draw here for the first and second diagram, and we need to measure this length because angle of inclinations we need to do it for the median to find out the beta angle, right? So go to arc by center and cut the first arc of 21.65. Cut the arc. Now draw the locus line. Let's draw the locus line here. Again go to arc by center here. So take second arc length 15.31. Okay, from this reference point, type radius 15.31, enter and cut the arc. Okay, now join. So just take this move command, take this reference point, so place it on this reference point. Go to rotate command and take this length and rotate and place it exactly here. Yes, zoom in. Okay, zoom in and place it. Okay, now extend this angle line so that you will get beta angle. So this is the procedure, guys, to do the beta angle. Okay, So now project it upward to complete the final position. Guys, thank you all. Thank you for watching my video. So you can join to my channel by only a less price of 119 rupees per a month, because exams are approaching. If you want to have any doubts or you want to revision, you can ping me in my channel. Okay, and after your exams you can cancel that recurring amount. Okay, so I encourage you people to join to my channel by paying 119 rupees. Then after your exams you can cancel it. So that's an easy way. Thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you all. Welcome to Engineering Visualization channel. Today we are going to solve problem number 2 from projection of solid in model question paper 3 VTU computer aided engineering drawing. So I want you people to watch the video till the end so that you can able to understand step by step procedure how we are going to complete this projection of solids. In that we have the hexagonal prism problem with beta angle. Okay, so you need to follow each of the steps one by one. You can see in this video I am able to solve this problem within less than 15 minutes. Okay, so what is given in question? Hexagonal prism, 25 mm side of base and axis 60 is resting on one of its edges of the base on HP plane. Draw the projection of the prism when the axis is inclined to HP at 45 and VP at 30 degree. That means angle of inclination in this problem they have given with respect to axis for both HP and VP plane. So that means it is an beta angle question. Okay, that means in this problem we need to find out the beta angle. Okay, first we need to, okay, in order to understand this problem completely and want to see the similar type of problems, okay, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, now the same problem I'll take from the solution book like this. Okay, like this we need to construct in the solid software. Okay, why I'm completing this problem in solid software means, so 80% of your marks is there in the solid software, that's why I'm not doing the sketching. Okay, xy line it is written bphp. Now we need to construct the hexagon using polygon by center command with respect to the edge here. So construct the hexagon, take smart dimension, give the length 25, it will change. Okay, now write the notation, top views and bottom view notations. Top views notations are written with ABCD and bottom face notations are written A1 B1 C1 like that, but it should be written within brackets. So here we need to find out the center of the hexagonal prism. So for that at least one or two lines need to be drawn, because since it is a prism, to find out the center of the axis no need to draw all the lines. And here inside of this hexagon we should be drawing the thin lines. No need to draw the thick line, thin line should be drawn here. One or two lines is enough. Okay, you can see in this problem I have drawn the three thin lines. Okay, since it is a prism we should be drawing only the thin lines, not the thick lines, and mention O1 and close the bracket. Now draw the projection lines upward to complete the front view. So draw the projection lines upward here now. So axis of the prism it is 50 mm. 50 length. Okay, enter. There is also 50 So okay, so write the front view notations, so which are visible from the front view, so mention it. So from the front view, A dash, B dash and C dash visible, D dash, E dash and F dash not visible. So not visible means we should write within brackets. Same way for the bottom face also we write the same thing. So now we need to copy the same diagram using move command. Okay, and we need to incline with the base head. So inclination to base head is given. So actually they'll give angle of inclination to the axis, but we need to incline with the base edge inclination. Okay, it will be easy in order to do the inclination. So use the move command, creates a copy, slide along the XY line and go to rotate and take the base edge. Inclination it is 45 degree. So incline 45. So it has been inclined. Okay, now extend the axis, find out the angle and project downward to complete the second position, top view. So draw the projection line downward here. Draw the projection lines downward to complete the second position, top view. Guys, subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications. Okay, write down the namings now. First I'll start from the bottom face. Now I'm writing for the top face, that is ABCDE F. Okay, now first we know that to construct the second position top view, first we have to draw an outer boundary line. Guys, you can join to my channel by rupees 119 per month, and then you can cancel after the examination. Now from the top face it is visible, so complete the hexagonal face. It is visible from the top face. So drawing the hidden faces with the dashed line. Okay, finally there is an axis. You can join from O1 to O. So it is in beta angle problem. We need to find out the beta angle in this. So the procedure is simple. You need to draw an angle line first. So angle it should be drawn for 30 degree. Okay, you can modify it just by doing like that. Okay, select this entire thing and then you can move it. First arc length of 50 mm we have to cut. Okay, 50 mm cut the arc. So draw the locus line. Now take this length of O1, 35.52. So cut this second arc length on the locus line. Then join using axis. Now we need to copy this second position top view and transfer using move command. Okay, project it upward to complete the final position. Thank you all. Thank you for watching the video. You can subscribe to my channel and hit on the like button and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching my video. Complete the final position. Welcome to Engineering Visualization channel. So today we are going to solve question number 3 in the model question paper 3 of Vtu-Caed, computer aided engineering drawing. Okay, so make use of the video. You can watch till the end. You can able to understand each and every step of the problem. So here the problem number 3 of the model question paper 2 is nothing but isometric problem. Here the sphere of diameter 50 mm rests centrally on a cube of sides 50 mm. Draw the isometric projection of the combination. It is nothing but the problem number 1. Okay, so you can see in this question, so we need to construct a cube. Above it we need to construct the sphere here. So first I'll be drawing an reference line. So please follow the step by step. You can able to understand the problem clear and easily. Okay, so reference line drawn. Okay, here we need to construct the cube first. So this cube of sides 50 mm. 50 mm means we need to consider 50 mm box. So here please consider the angles. So from this reference end, length will be 50, angle is 30 degree. Okay, again length is 50, angle is 180 degree, 150 degree, sorry. Then another angle is, again length is 50, angle is 210 degree. So like this we need to construct the box. Okay, now vertical height we need to give the height of 50 mm. One line I will draw, length of 50 mm. Okay, then go to move command, creates a copy of it, or either you can directly do it like this. Okay, length 50 mm directly we can do. Angle is 90 degree. Okay, now construct the top face. So here the cube construction it is done, guys. The cube we have constructed. Above it centrally we need to place the sphere here. So that is also having dimension 50. But guys, you know that sphere will be constructed with the actual scale, but the cube we need to convert into isometric here. Okay, so that is the important thing you should. Okay, you can keep it like this, then you can show the angle. And this is one of the basic first problem of the isometric projection, guys, and this problem can be asked in the exam. Okay, so find out the midpoints. Height we need to find out. This is the center of the box. Center of the sphere will be find out. The height will be 25. Okay, now after finding out the height we will convert into iso. Okay, so this step you remember, guys. Go to scale here, type here 0.816 or 823, can type it. Okay, now go to circle and draw here. That's what the center of the sphere. Now go to circle and draw circle of diameter 50. Enter. So that completes the sphere here. So always remember, sphere will be drawn with the actual scale, other solids will be converted into iso. So you can check the dimensions here. This will be 50 sphere actual dimensions, but if you check the dimension of the cube it is less than 50, but after converting to iso it is converted into less dimensions. Okay, thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you, guys. Thank you all. Hello guys, welcome to Engineering Visualization channel. Now today we are going to solve model question paper 3 Vtu-Caed and problem number 4. Okay, so many of the students have been requested me for solving model question papers from Vtu, because this time we will get the question papers from Vtu only. Before that, the internal and external examiners are preparing the question paper, but from this semester the question paper you're getting from the Vtu. Okay, so I'm trying to solve the question papers, guys. Try to get the help more out of these videos. Okay, so here the problem number 4: pentagonal prism of base side 30 mm and axis length 60 mm rest with its base on HP, and at the end an edge of the base inclined at 45 degree to VB. So that means we need to place the pentagon with respect to an angle of 45 degree to VB. So it is cut by an plane perpendicular to VP, inclined at 40 degree to HP, passing through a point on the axis at a distance of 30 mm from the base. Okay, so develop a remaining surface of the truncated prism. Okay, so first we need to construct an pentagon here. Okay, and then we have to place that pentagon at an angle of 45 degree to VP. Okay, that's how we have to proceed with this problem. Okay, so draw an XY line, and here pentagon will be constructed, and its edge has to be placed on 45 degree angle line. Okay, so for that, first I'm drawing an 45 degree angle line. So angle line of 45 degree is drawn. Now we have to go to polygon base center command. So construct the pentagon with the edge. So here number of sides we need to take 5. Place it with the edge and go to smart dimension and give the dimension now. So dimension of 30 mm. Okay, now you place the pentagon with respect to the edge on this 45 degree angle line. So go to move command and select this pentagon with respect to the end corners. Now go to move rotate command and place it with respect to the edge. Okay, so now it is done. So the first position top view it is done. Now we need to give the naming for this. Okay, for the naming purpose I'll be writing only the top face notation. I'm not writing bottom face because here I'm concentrating more on the construction part. After giving the namings, we need to draw at least two or three perpendicular bisectors, okay, to get the center point. So after drawing the front view, so we need to draw the projection line for this end also. Okay, so draw a length of 30 mm from the base. Okay, so at this point we need to draw an section plane. So angle, you can see here, angle of 40 degree. You can draw angle line like this or like this on the both the sides. You can draw, no problem. I'll draw here this side. Okay, randomly I'll draw a line, then after that I'll change the angle. So this problem, guys, I have not did in development of lateral surface of solid. You can refer this particular problem, because this problem in pentagonal prism I have not did, so it can be helpful for you to refer in the exam. So angle of inclination is 40 degree. Now you can extend this section plane. Okay, so section plane has been drawn at a height of 30 mm on the axis at an angle of 40 degree. Now you can write down the cut points. Okay, one, it is on the vertical edge of AA, and 2, it is on the vertical edge of BB, and 3, it is on the vertical edge of CC, and D, it is on the vertical edge of DD, and 5, it is on the vertical edge of EE. Okay, so software, it is taking a loading little bit of slow. Guys, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates in the WhatsApp group so that they can also be benefited from this. Okay, we got the cut points. Now we need to draw the development of this. We know that prism will be drawn using parallel line method, so we'll be drawing the parallel lines here. Okay, so one vertical line you can draw, and then there are 5 faces in the pentagon, so we can draw at a distance of 30 mm. Okay, can give this as a go to offset command and select this particular line, and then offset at a distance of 30 mm. Can give the distance now 30, and click on accept. Okay, 5 lines we need to draw, 5 faces. Okay, now just wherever we got the cut points, right, from there we need to draw the horizontal lines we need to draw from 1. Can give the naming here in capital B, capital C, capital D, and A. Yes, the cut point of 1, it should be on the vertical edge of A. That's why I'm just extend it, so you can mention now. Same 2, it is on the vertical edge of B, phi, it should be vertical on the vertical edge of E. Okay, and then 3, it is on a vertical edge of C. 4, it should be on the vertical edge of D. So now we need to write the cut points names. So 1 on a vertical edge of A, and 2 it is on B, 3 it is on C, 4 it is on D, and 5 it is on E. Now we need to connect all these points using straight line. You can click on the bell icon because I'm going to upload all the model question paper solution to this channel. Okay, make use of it for the exam. And I always tell that for the revision purpose you can refer to this channel, because during exam time you are going to forget all the concepts. What is the concept you have been used for normal type or beta angle or appears to be, okay, whether it is in planes, solids, or in isometric. Development, for the development purpose, it is the best channel, because in many of the channels you may see they maybe have done only some 2, 3, or 5 problems. Okay, but in this channel you get almost all the types of problem. So I have taken so much of hard work for you people. Okay, make use of the videos. You can take any of the problems, either it is cone, cylinder, prism, pyramid. All the types of problems have been solved in this particular channel, so make use of it. Okay, and if you find this channel helpful, you can subscribe and hit on the like button and hit on the bell icon for the latest notifications. Think problem is completed. Thank you guys, thank you all, thank you for supporting this channel, thank you for watching it, and make sure you share in the WhatsApp group of your classmates and friends so that they can also be benefited from this particular video. Okay, thank you all, thank you for watching it.